All right, well, hello AP Physics students, and welcome to this video lecture, which is going to start out by looking at question 10 from the problem set that we were working on Friday. And then it's going to kind of go through an example of how we can use this idea of gravitational potential energy to solve for the escape velocity of a rocket. Okay, so first things first here, problem 10, or pseudo number 3, whatever we want to call it. We're looking for how much energy is required to move a 1,000 kilogram mass from the Earth's surface to an altitude equal to twice the Earth's radius. Okay, now we know that we have to do work against the force of gravity here. And I want us to understand conceptually a little bit better what's actually going on when we're looking at gravitational potential energy as things are moving away from the planet Earth. Okay, so in this problem we're focusing on this distance 2r plus this radius, but understand that as we get further and further away from Earth, let's say that our distance from the center of the Earth, r approaches infinity. Okay, so we're getting infinitely far away from Earth. Well, what does that actually mean for the force of gravity that object is experiencing? Well, that means that this value is essentially moving to 0. Okay, if this gets bigger and bigger and bigger, this gets smaller and smaller and smaller. Okay, well, what does that mean in terms of our gravitational potential energy? Okay, remember this was our equation that we had for gravitational potential energy. So it's the same idea here. If we're getting infinitely far away, then this is getting infinitely small. So as we continue to move out this way, we have to do less and less work against the force of gravity because it gets smaller and smaller and smaller. Okay, so that's a really important idea for us to think about, and it's kind of a weird one to think about, right? Because we're so used to looking at gravitational potential energy in a uniform field where we say, well, actually the higher, the further away an object is from the ground, the more energy that it has. Well, that again works in only the uniform field where things are nice and neat close to Earth, but when we get further away, we need to be mindful that the amount of energy that object has actually decreases. Okay, so with that being said, let's solve this problem. So we're moving from this point here to a distance of 2r. Okay, so 2 times the radius of the Earth away. So we actually have work being done here. We have an initial amount of energy, so I'm just going to say E initial here, and we have a final amount. Okay, and we know that work is simply a change in the amount of energy that object has, so we're going to say work is equal to E final minus E initial. Okay, now the energies that we're dealing with obviously are gravitational potential energy at our 2 snapshots here. So we're just going to use this equation that we were working with on Friday. Okay, so let's plug in our, well, let's just write this out algebraically first here. Okay, and we have r. Now r final here, we have 2r plus r, so this is actually going to be 3r. 3r. Okay, minus divided by r. Okay, so this is what we're left with here. So notice that I have 2 negatives here, so that's going to turn into a positive, right? So we're actually going to be adding this amount to this amount here. Now if we just plug and chug here, plug in the stuff that we know, the amount of work or the change in energy that's required to move that object is going to end up being 4.2 times 10 to the 10th joules. Okay, now this result, this positive result, this is actually showing us that we started out with more energy than what we ended with. And that should make sense based on this conversation that we started this video lecture out with. Okay, the further away we move, the less energy it has. Okay, so we actually have positive work being done here. Okay, All right. So, as opposed to me talking about escape velocity and in the sake of me conserving my energy and time, there's a really good video that I found which explains what escape velocity is and shows the process of how we can determine what that is using conservation of energy and our new understanding of gravitational potential energy. So that video is in Google Classroom. So I want you to watch that. Again, getting a little more context into this idea of gravitational potential energy as things are moving away from the Earth, and then get a little practice with the problem set that I have posted. So please make note of any problems that you may have difficulty with. We'll take a look at those on Tuesday. Okay, so take care, AP Physics students, and we will see you tomorrow.